you feel best represents you or one of your interests. So my name's James Dwyer, and I'm one of the 2 LEGO certified teacher trainers at Modern Teaching Aids. And as I mentioned before, we've got one of the Queensland reps, Chris Todd, on the chat function to answer questions. So, now, to give you an idea of what we'll be covering in today's webinar, we'll be reviewing what resources and programs you need to code the EV3 in Python. We'll review some examples of what online resources are available to support learning Python. And we'll cover some simple coding examples and learning strategies that will allow you to develop your confidence in Python or working with the EV3 if you already happen to know it. So, and that leads into the next point, which is, I guess I'd like to clarify that it's likely we have 3 different groups amongst the attendees. We've got those who are familiar with the EV3 and are interested in how to use Python with it. Then we've got those who are probably very familiar and experienced with Python, who want to understand how the EV3 could be used to make teaching Python more engaging for their students. And then we've got those who might be new to both. And so as much as possible, I've tried to tailor the webinar around the likely needs of all 3 groups, which means I need to cover some of the basics of both the EV3 and Python. So my apologies in advance if some of the stuff I cover is already more than familiar to you. So with this particular slide, I always like to include this in my presentations because I think it's a really powerful reminder of what we're trying to achieve. In essence, everything LEGO education develops is based on Seymour Papet's theory of constructionism. The central idea in Papet's theory is that we learn best through play and experimentation and exploration. And combining the EV3 with Python builds on that theory and is such a great way for students to learn both text-based coding and robotics. And along with the other sort of associated learning outcomes, such as problem solving, logical thinking, creative thinking, and that sort of those things which naturally come out of learning robotics and experimenting with it. As you delve into the online learning, the unit plans that LEGO Education have developed around the concept, they've developed them around the concept they've termed as hard fun. Okay, you'll find the activities should be joyful, they should be meaningful, they should be engaging for the students. They should be iterative, so they're going back and reviewing and revising what they're learning and reinventing. And the other one is it should be socially interactive. The ideal situation is that students are working in pairs and they're learning collaboratively. Okay, so to get started, the things that you'll need, okay, obviously you need the LEGO EV3 set, and the ideal numbers, as I mentioned before, is to have 1 set and the kids working in pairs. So it's a 1:2 ratio. Then we've also got the micro SD card, which you'll need to insert into the side of the EV3. That's what the Python operating system is, how you load it up, if you like. And then we've also got the Visual Studio Code, which we'll show you, and I'll show you where to download it and those sort of things as well. So there's a really clear getting started guide with Python. And we'll have a look at that in a moment. It's on the LEGO Education website. And but first of all, I just want to make those who are new to the EV3, give them a little bit of an understanding of what we're talking about. So here we've got the basics of the EV3. We've got the EV3 brick, which is the microcontroller that we're going to be programming. Then we've got the sensors, and we've got the touch sensor, the gyro sensor, and the color sensor, and the ultrasonic sensor. That's how we get information into the microprocessor, so we can then decide what we want to do with it, whether that's display on the screen or play sounds or make the robot move. And so with the kits, you get 2 large motors and also a medium motor. Okay. Now, then we move into the Lego itself. Okay, and that's sort of, it uses the Lego Technic building system. And so you end up with these structural elements which hold your model together. You've got the connector elements, which allow you to link pieces together. We've got the movement elements, which allow us to create gearing and motion in our models. And then we've got the decorative elements as well, which can be used to create detail and give character and give context to the models that the students build. Now, there's another factor that makes the EV3 robotic system so great, and it's in particular, it's what I like. Unlike some of the other robotics platforms out there, it's not always going to be the same type of robot, like a ball or a fixed model. Using the Lego Technic, students can easily, safely, quickly, and cheaply prototype their ideas. They can literally make their own creations, whether it's creating an autonomous vehicle or a Rubik's Cube solver, or simply modeling doors that open automatically. Students can quickly construct robust models to demonstrate their learning. These models can be broken down, and this is one of the things I really love. These models can be broken down and can be reused over and over again. And that's just one of the reasons why I think the Lego robotics platforms are such excellent systems for students to prototype their ideas. Right, now we'll jump onto the web and we'll have a look at the Lego websites. So to get started, and Chris will add the links onto the chat function either at the end or during, but if we were coming in and we just type in EV3 and Python. So just typing it in, and the first site you'll come up with is this. It's a Lego education website. You can see here it's got education.lego.com. So we click into this, and it brings up, this is where you get started. If you're not sure how to start, you come here, and it gives you the this getting started guide, and we'll click into that in a moment. I'll just click on it and then jump back to the other one. And then we've got the micro SD card image. This is what we have to load onto that little micro SD card that we're going to put into the side of the EV3 brick. Then we've got an online documentation and some example programs. You can click on there and it takes you to this. This is the user guide that's inside the Visual Studio Code software as well. So we can come back to this after and we'll have a better look at it. But for the moment, we'll have a look at that getting started guide, which I clicked on here. This was the top link. Okay. So you come in here, and recently Lego Education have done an update and they've gone to version 2 of the MicroPython for EV3. And there's some really great improvements that they've done as well. So you've got a table of contents. In here is just the installation and the very basics of creating a program. So you scroll through and it's set out really clearly, and it's things like what do you need? And it's really specific down to the type of micro SD card that you need. It tells you that you've got to use one that has a capacity of greater than 4 gigabytes, but less than 32. And it gives you a few other details to have a look through before you go out and buy an SD card or what you're going to use. The other thing you might want to look at is, say on my computer, I use a Surface Pro, and they don't have the ability to read a micro SD card or write to it. So I just went onto eBay, grabbed one of these little USB sticks for about $5 or $7. Then we come down, and so I use that to write the image onto the micro SD card. Okay, then we come down to the other sort of things, and this is how you'd need to set up. It's a really good, easy guide to follow through. Then it jumps onto the software you've got to download. This is the software we'll be using and the extension that we'll have to download. I'll show you that in a moment. And it even comes back to this step of preparing the micro SD card. Tells you the software here that you've got to download, it's Etcher, and you can download that. And it shows you here the image. When Etcher starts up, you've just got to select the image that you've downloaded, select the drive that the micro SD card is on, and flash it. And it's that simple. And essentially you've got the operating system on that micro SD card ready to be loaded into the EV3. Okay, so here it is. There's a nice little tip there, and I do this where I stick a bit of sticky tape on there, because if you insert that SD card in, it goes in flush, and it's really difficult to get out with you unless you've got long fingernails or a set of tweezers. So a little bit of tape on the end of those is a great idea. And then in here is the process of turning on the brick, loading up, navigating through the menu. If you want to have a look, you can go through and have a look at the sensor values in the operating system, those sort of things. See what values you're getting on the motors. All that's available to you. You just have to navigate through it. And then the other thing is to go back to the original software. So the EV3 bricks themselves start with there's a standard Lego software or firmware that you put on there, or operating system. And you put the SD card in, it loads up MicroPython. Once you shut it down, you pull out the SD card, start it up again, and it starts up with the standard Lego firmware. So you don't have to worry about reinstalling that or anything like that. It makes it really simple to use. One of the things to note though is when it's loading up the Python software, it takes probably about 2 minutes to load up. So it's quite a while to wait, whereas the EV3 software fires up in about 40 seconds or so. So it's just something to note when you're managing classrooms. And then you come in here and it starts the process explaining how the programs run, if you like. And we'll have a look at that in the Visual Studio Code software ourselves, and how to open a project, that sort of thing. Okay, so that covers that off for the moment. I'll just, all right, okay. So now we'll jump in to the Visual Studio Code. When you start it up, this is what it'll look like. I'll just expand that out. Okay, sorry, this is what it'll look like. I'll just close that. And when you've first installed your Visual Studio, it will start up with something looking like this. Obviously the recent won't be in there, but it will be similar to this. And there's these tabs down the side. You'll start with five tabs, and then there's this sixth one which you need to install. Okay, this one won't be here. You can see it's the Lego EV3 symbol. So you come in here to extensions. You've got to click on that. Okay, and in here, you've got to remember Visual Studio Code is a proper professional coding or development environment. Okay, so if you come in here, there's extensions for Java, there's extensions for HTML, all sorts of C#, all sorts of languages that can be coded. In our case, we're looking for the EV3. So we just type in there the EV3, and you get a list. There are 3 different extensions that you can load up. The one we're looking for, if I click on this one, okay, the one at the top comes up with that Lego education symbol. That's the one we want to install. So you come along here and you can see I've already installed it, and you can just click on install and make sure it's installed. Once that's installed, this will appear here, this tab here. And that's where we come into to load up all our, this is where we sort of create programs, that sort of thing. So Lego Education have gone through and created this extension, which makes it really easy to program the EV3 specifically, all the files you need, that sort of thing. So you come up here, we can create a new program, but before I do, I'll just show you these 2 things. There's you can explore some sample programs. This is one of the new things in the version 2 of the MicroPython, which they've done. And in here, you can do some data logging experiments. There's other sample projects you can pull up, and they can be really useful. For the moment, so there's some from the extension, expansion packs. There's some of the ones from the basic core sets. Okay, so you can go in and explore there. The other thing is you can open the user guide, and this is a really handy bit here. This is that, that section on the web that we were on before, okay? And I'll come over here and I'll just shrink that up, okay? And in here, actually, I'll make it full for the moment. Okay, in here is again that guide if we were installing, preparing the micro SD cards, creating and running programs. You can see you just click on the menu at this point and it opens up over in this section here. And there's also things about understanding how to program the hub, okay? This is where things like classes and methods, for those who are familiar with the Python, this is where you would go to navigate to start understanding how to code specifically the EV3 if you're already familiar with Python. Okay, but we'll jump out of that for the moment. If that's not, if some of the language I'm using isn't making sense to you at the moment, that's fine. We're going to come back to it. So I'll just close some of this up. And get my screens organized. All right. So now we want to create a new program. So come in here and it's asking me to name the program. So I'll just call it webinar. And obviously it's using, it's fairly old school. You can't have things like spaces and things if you want to use two words or two words separate. You've got to separate them with an underscore, that sort of thing. So webinar test 2. Okay, oh, actually I might have 2 in there, so I'll do it as 3. Okay, so so I've now named it, and now it's asking me where I want to save that particular file. So I've got it in here. So in this file is I've just got it in a rubbish file for webinars. So the sort of code that I'm doing. Okay. Now I've come in and it's changed slightly. We're up in these. I showed you this extension section where we loaded in the EV3 extension. This is where we can start our programs, that sort of thing, and get to the user guide. Now we're up here in this third section, the Explorer section, and this is where our code is. Now, when it opened up, when the extension opened up, it opens up all these other files that are necessary for to make it interact with the EV3 brick. But the file we're most interested in is this main.py file. This is where you create the magic, if you like, that makes it all work. Okay, and just to run through, this is a blank file. This is how it opens up. It comes up and it's got these comments, these green sections of code. Okay, they're not actually code, they're comments. So this is where you write explanations, if you like, for yourself in future, if you're coming back to your code or to help you to understand it. Okay, you'll write in explanations of what different sections of code are. So you can see here, you create your objects here. Don't worry about what that means for the moment if it doesn't make sense to you. Okay, and you write your program here. Okay, then we jump into this big block of code up here. This is where we import the libraries, okay? This is where all the code is that allows us to interact with the EV3 brick. And so there's all this, what they refer to as libraries, where all these sort of code sequences and classes that we can use to code the EV3 brick itself. So we come down here and we've got, as I said, creating objects, and the only bit of code in here that actually runs or does anything in this program is this ev3.speaker.beep. So it's going to test that the actual brick works and it beeps. So this is a bit like a hello world sort of program. It's the very simplest program we can run. And what we want to do is have a little look at whether it runs. Okay, so first of all, I'll just swap it over to the, we'll grab the brick itself, we'll plug it in. Okay, so I've plugged in the little USB cable into the EV3 brick. And now I want to connect up and run this program. So what I need to do is make a connection down here, okay, in this section. So we're in the Explorer section. Come down here and you've got the EV3 device browser. And you can see here, if I click on that, I come in and this is the one that I want to connect to, this Ethernet 17. Okay, even though it's on USB, it refers to it as Ethernet. We click on that and it goes yellow. And at this stage, it's sorting out. Once it goes green, you're good to go. Okay, so if I run this program at the moment, to run it, we've got to come, so we're in the Explorer tab at the moment. To run it, I come down to this section where it's got debug and run. Click on that and this menu here changes and there's this little run button there. There are shortcut keys you can use, but for the moment, we'll see. So it's just gone through, it's debugged it. and it ran. And you can see here down on this output section, I'm getting confirmation that it ran. Okay, I'll put it up near the speaker, up near the microphone. You might hear it beep. Okay, and that's as exciting as that program is. Okay, but that just tells me we've got a connection to the brick itself. We can get programs to run. So that's a great start. If you've got that far, you're on your way. Okay, so the next thing we want to do is start creating our own sort of program. And I can see up here we've got all these classes. What I want to do is, rather than connect up a motor or a sensor initially, it might be helpful to explain an essential part of Python coding by using this idea that we have to create objects. Okay, Python is an object-oriented programming language, which means we have to create objects from classes. So if we have a look up here in the library, I'm going to create something that it isn't tangible, but it will be in the code. And we're going to create a stopwatch. Okay, so here, where it says create objects here, hopefully that sort of line EV3 equals the brick, EV3 brick, will make sense to you after I go through this explanation. So the first thing I want to do is I want to create an object like a stopwatch. And essentially, it's a bit like, in terms of, if you think of it like wizards and magic, we've got to, before a wizard can, say, throw a fireball or something, you've got to conjure it up. You've got to conjure up that fireball, and then it'll have certain characteristics, like it'll be hot and, you know, it'll burn things when it hits it, that sort of thing. So the wizard conjures up the fireball, and we're going to do that. And it's called initialization, or in this case, Lego, I've referred to it as creating objects. So we've got to initialize an object called a stopwatch. So here, I can see up here, it's written there, okay? So I'm going to give it a name, my timer 1, and equals stopwatch. And you can see there, there's some autocomplete or auto completion of text, that sort of thing, or predictive, almost predictive text, okay? And afterwards, I'm going to put those brackets in, okay? So now I've created a stopwatch. Now I could create my timer 2, my timer 3. I can create as many as I like, but they all have to have unique names so they know which one I'm referring to. And I might use a timer to measure motors, to measure lights or sound. So I might have a number of different timers running. But in this case, I've got my timer, okay? Now I want to come down here and I want to use, now one of the problems at the moment is I've created this stopwatch, and in the real world, a stopwatch has features like you can start it and stop it and reset it and pause it, those sort of things. And I want to learn more about the stopwatch. So where do I go? I can come down here. You remember that user guide? That's where this becomes really critical. And here it is, it's opened up this user guide, okay? And I'm just going to shrink, because we're going to share the screen with this user guide. So when I click on it, you can see you've got that menu down the side here. And in here is where we can find out about this class called stopwatch, okay? And you can see here we've got hubs and EV3 devices. So that's where you'd find out about things like motors and how to use the touch sensor, that sort of thing. And down the bottom here, we've got this one, or not down the bottom, at this point here, we've got timing and data logging. And I know that the stopwatch is in there. And here you see, we've got this class stopwatch, and I created one called mytimer1. Then we've got these methods that we can use in here. So methods are like instructions, if you like, okay? And one of the things I want to put in there, so I want to use the stopwatch. First thing I want to do is reset it. So even though it's only just started, mytimer1, and I want to use the method .time. So I come in here, and that instruction there, sorry, is I wanted to use reset. So I'm going to change that to reset. So you can see down here, and that resets the stopwatch. So if it was a physical stopwatch, it'd be stopping the button and resetting it to 0. Then we've got the instruction EV3 speaker beep, okay? Then we want to wait. We're going to wait. So you can see up here, some of these classes have arguments or parameters that you need to give to them. And up here, I've got the wait command. You can see here, and it's got a, you've got to tell it, you've got to pass the parameter and tell it how long you want it to wait. So I open the brackets and I tell it that I want it to wait. And you can see here, it's in milliseconds as well. So I want it to wait 100 milliseconds. So 1,000 milliseconds is 1 second, 100 would be 1/10. Okay. So after I've waited a millisecond, I want to find out what the value is on the timer. So we can find out, so I come in here, my timer, it comes up there, you can see it auto predicts what I'm trying to write, or auto completes, okay? And so I've got my timer and I want to know what the time is. So there's this function over here with the brackets after it, and it says get the current time of the stopwatch. So pop the brackets in there and it's going to tell me what the time is. But it's one thing to get that information. I can save it to a variable, but I can also just print it. There's a print function you can use there where I will print it and it will print out here. I could print it to the EV3 screen, but you're not going to see it. So here I'm going to use a print function so to output the how long it's taken. For the, once the time is reset, I can find out how long it takes for the speaker to beep, and then it waits 100 milliseconds, and then we'll get a readout. So if I jump in there, come up here, and okay, we've got it running, and you can see there that it takes, okay, so this is our output here, this 202 milliseconds. Okay, so between the time it's waited 100 milliseconds there, chances are that speaker beep is 100 milliseconds in itself. So we've got 100 milliseconds of beep, then we've got the wait for 100 milliseconds, and the other 2 milliseconds are used in the print command and possibly just for the computer to take the time to actually execute those commands. So you can see that it's really fast. Okay. One of the other little features that I think is really cool in the Python, it's a new feature that they've just introduced, and it's this one here, using the speaker, and it's new, and it's this speaker.say. Okay, so we've got our EV3 speaker here that we can give commands to the EV3 brick through. They created this object up here, the EV3 brick, okay? And if I want to add in there a command, I can go EV3 dot, and then I could copy the text from the other side. I don't know if I did. Oh no, yeah, okay, I did. So I've got, wait. So now I can put text in there, just straight text, anything you like. This is, so let's say we go with this is awesome, and perhaps it's better if I spell it correctly as well. So there we go, and we close the brackets, and now hopefully this will work for us, okay? And if I just run it, it should go through, and we'll just find out. Looks like it's going to work. All right. Now, I'm not sure whether you could hear that, but the EV3 speaker just says whatever's typed in there. Yes, you'll get kids, they might use swear words, that sort of thing, but at least if they're getting the EV3 to use swear words, they're coding, and that's the optimal. They'll get sick of typing those things in, but it's a great feature for creating that more interactive robots or systems, whatever you're trying to produce. So that's a lovely little thing. And you can see there that given there was the last time we ran it, it took 2 seconds to 200 milliseconds to do the beep and wait 100 milliseconds. It now took about 3.5 seconds to say this is awesome. So you can see how that clock can be used to see how fast things are happening, that sort of thing. All right, that is basically the beginnings of sort of coding, if you like. Now, the next thing I want to do is add in a motor. Okay, I've got a little trick here. So I come up here and I'm going to add a fan, if you like. So my fan, okay, and I'll just swap over the video camera so you can see it. We're going to code it in a moment. Okay, so you can see here, I've got this fan that I want to use, okay, and we've got a touch sensor that we're going to use in a moment as well. So we jump on, come back up here. I've got to initialize a motor in order to be able to use it. So we come up here, my fan equals, and we're going to use motor. And here, if we come back to this guide again, and we want to learn a little bit about how to initialize motors, we'll come back up here, go to the EV3 devices. You've got their motors, and you can see here we've got pictures of the different motors. So here's these commands will handle the medium motor, the large motor, and the NXT motors as well. So come down here. When we're conjuring up a motor, if you like, we've got to give it some parameters here, and the parameters are explained listed up here in the instructions, but also explained down here. Okay, so we've got things like port, or if you want to change the direction, whether you want it to move in a clockwise fashion or anti-clockwise fashion, you can list that here. And depending which way you orientate your motors in a model, that sort of thing. So we've got my fan, and then I know that I have to call it a port, okay? And in this case, on the little screen, I'm going to connect that up. Wait a minute, when I find which way it should be orientated. Connect it up. I'm going to connect it up into port A at the top here. So I've now got a motor connected in, okay? And I've got to tell it that it's connected to port A. So you can click on that and it'll come up here and it'll tell you the ports are listed as A, B, C, D. Now, sensor ports are listed as S1, S2, S3, S4, okay? Rather than 1, 2, 3, and 4. So you've got to remember that we're using S for sensor ports. Okay, so if I drop back up top, okay, we're back here, and I know that I have to put in the EV3 port.A. Now, at this stage, let's say you didn't know that it had to be port.A, you might think it's port equals A, something like that. If you're not sure, you can come down here, and this is a really great little feature here. In the menu here, they've got programs here. You can just jump in here. Let's say I don't know how to set up a motor. I come down to this elephant one and look through the code, and I can see here's an example where someone's initialized a motor for the purposes of the elephant program, and they've called it the legs, okay? And I can come down here, Control V, and I can paste it in and I can modify it to suit my needs. So let's say I had called it equals A, that sort of thing. You can see here in the sample code that, okay, I've done that wrong, and dot, okay, put A. Now these other parameters like direction, so I'll just jump back to where we were with the instructions for the motors, okay? This is how you would need to write it like this, direction dot counterclockwise. Capitalization is really important with Python. You need to make sure you get that right, otherwise it's not going to compile, you're going to have errors, that sort of thing. So you've got to remember it's counterclockwise, not anti-clockwise, all those little things, but you can have a look through in here and get the, I'm over here on the user guide here, and you can click through and get the correct capitalization and wording here for those sort of things. You'll start, the more you play with it, the more you understand how to navigate this user guide to get there. So, okay, so I don't have legs underscore motors, so I'm going to delete that, okay? And I just want I'm happy whichever way my motor turns at this stage. So I've now conjured up or initialized a motor, okay? Now I want to do something with it, okay? So we're going to come down here. I'm going to get rid of this EV3, going to get rid of that little bit of code, okay? And I'm going to run Okay. So I might, I'll comment out that code. I don't need it for the moment. So I can just go like that. And suddenly my code is commented out. It's not going to be part of the program. So I'm going to reset the, I don't mind if it resets. Then I've got the speaker playing. Then I'm going to get my fan.run. Okay, so down here in the motors, okay, I've got these sort of methods or instructions that I can give it or use to return information. So we've got measuring, where I can get the speed that it's currently traveling at, or I can get the angle of the motor or reset the angle. I can also stop it using, you know, stop, break, or hold. And there's a difference between those, and you can play around with those at a later stage. I won't go into it too much depth, but I've got here this one, this run for speed. So I'm going to my fan.run, okay, and I've got to tell it the speed that I want it to. The parameter here is speed, and here, this is the rotational speed in degrees per second. So I'm going to tell it to turn, if I told it to turn at 360 degrees, it would turn 1 rotation per second. It'll go up to a maximum of about, in theory, about 1,000, but it starts to get a bit unreliable above about 800 or so. So you can see there, I've got that incorrect, okay? And so now, if I run that program, it should turn the motors, but there'll be a little bit of a problem with it. Okay. Okay, now I heard it beep. I'm getting feedback down here that it completed successfully, but something seems to have gone wrong. What it is it's executed exactly as I told it. And if you remember how quick things are happening, it resets the timer, it does the beep, and then it sends an instruction to the fan to run at a speed of 500, and then it comes down here and ends the program, okay? What I need to do, it ends before it actually gets up any speed. So if I put in a wait command, and I tell it to wait for 1500 milliseconds, 1.5 seconds. Now if I run it, and we get it working, okay? If I, now that is one of the methods we can use. For those who are familiar with Python, you've probably already raced ahead and had a look down here. You can have it run for a certain amount of time. So there's another method I could use where after it runs for 1.5 seconds in that direction, I can grab this little bit of code here, paste that in, okay? I'll put a bit of space between them. And this time around, we're going to have it travel at minus 800, okay? And we're going to have it run for 3 seconds. As a negative speed, it'll turn in the opposite direction. And then I want it to stop. And you can see here, I put in some of the parameters, stop.hold, and I want it to wait there until it's finished. So if I run this program, you should see it spin in one direction for 1.5 seconds, and then swap direction for the other 3 seconds of the program. And so you can see how we can start building up our program, okay, and taking control of things. Now, at this stage, what I'd like to do is now we want to introduce the touch sensor. So very simple, it's either on or off. We're going to use that to control our program. At the moment, all we've really done is use separate commands. There's not any of the clever sort of coding in Python. This is all mostly EV3 sort of coding. It's just one instruction after the other. Now, if we want to learn a little bit about Python, okay, I want to use if this is pressed, then I want the motor to turn. If it's not pressed, I want the motor to stop straight away. So it'll only run while I press the motor. For that, we're going to need to use an if instruction, if the sensor is pressed, and otherwise we want it to, if it is pressed, we want the motor to run. If it's not, we want it to stop. So first thing we've got to do is we've got to initialize or conjure up an example or an object of this touch sensor. So to do that, I'll type in my switch. I'm going to call it a switch. You can call it anything you like. okay? And it's going to be a touch sensor. Okay, and then I've got to open the brackets, and if I come over to this manual again, this is just so crucial to be using this user guide, particularly early on. And it comes in, and I've got here touch sensor, and I've got to give it this parameter of what port it's connected to. So I've connected that up, and down here in the image, I can see I've connected it into port 4. So I type in port dot. And if you remember, it's not just 4, it's got to be S4. Okay. And so now I've initialized the touch sensor as a switch. And now I want to find, well, where's, I want to get this code for how to get this how to get it to work, this if else statement. For that, I'll come back out, and we start moving outside the Lego environment here, and we're going to move into this section here. Now, there are loads of sites on the web for learning Python. The one I happen to use, I don't know if it's the best, but it's good, is W3 Python, and it's w3schools.com. Free website, you can just go on there and use it. I've just clicked onto it, and it has everything. I'll just expand this out a little bit, and we should get a menu. There we go. So here we've got a menu on the side with all the different things that we can use. So you could literally come here and learn Python. So I'll just, while we're waiting, sorry, and I'm explaining this, I'll just switch off the videos because I know, yeah, because it might be obscuring your screen as I'm navigating through it, that's all. So we've got here, we've got, you can learn about syntax, you can learn about strings and booleans, and so strings are like text, lists, tuples, and what we were looking for is this if else. So if I jump into this if else, it'll give me some examples of if else statements. So you can see I want to find one that looks familiar. You've got if, elif, that sort of thing. Let's find a simple one. We've got this one, okay? So I'll come down, I'll grab that bit of code, okay? Now, you can jump in here, and it's a great little website, and this is where you can learn it, and it'll print a statement, and this is a Python editor that we're in, okay? So it's checking if B is greater than A, print this statement. If it's not, print that one. Okay, so it's just that simple sort of text, and you can change the numbers here. And if I delete that, make that 20, and at the moment where it was 200, B is not greater than. If I rerun that, it'll pop up and it prints B is greater than A. Okay, so you can, there's a little mini Python editor. You can do all sorts of examples in there. It's fabulous for playing around with. So I grab that little bit of text, I come back to the program, and we write the program that we actually wanted to. Okay, so we come down here. Oh, so I haven't actually grabbed that, so copy. And this is where you get your first sort of real lesson in Python to some degree. We've got, so I'll get rid of that. Okay, and this is where spacing is critical in Python. So we've got this, so some of you might be familiar with other text-based languages where you're using colons and brackets to determine what's inside different functions, that sort of thing. What we want to do here, we want to work out if, and we're doing the my switch. And there was a method there, if I jump back to it quickly for you. So my apologies if all this seems really rudimentary to you, if you're quite experienced, but we've got to take everyone through. So we're back with the touch sensor. We've got, and one of the methods is whether it's pressed, and this will return a value of true or false if it's pressed. So if dot pressed, and I should be able to, if I work this correctly, yeah, keep that there so you can see where I'm getting the the method from. So if it's pressed, okay, now that will return a true statement. And I could write in if pressed equals true, but that will be enough, okay? And what I want to do, I want to get in here. We're going to run the motor. So remember this little bit of code I grabbed before? But if it is, so we'll drop down, and you'll notice as soon as I drop down, it does the spacing correctly there, and it determines what's inside. It'll run that statement there. Then we come back. So if it is pressed, we want it to run at that speed. If it's not, so we'll come back, and you've got to have these sort of little things like semicolons, those sort of things, but you'll learn that along the way. And so my fan, and I want it to stop. If I go back into the motors again, and I want to work out, remember there was these stopping ones, okay? We're going to use hold, okay? Dot hold. All right, and then we want it to, okay. Now, one of the things here, if I run this program, and we'll do it quickly, okay, we'll get rid of some of the other stuff we don't need. So at this stage, okay, so that should work for us, okay, and run, and we'll get a little, I'll do a duplicate beep. Okay, and I'm pressing it, and I got a beep, but it didn't really work. You could see it moved. Oh, wait a minute, I haven't got the video going for you. My apologies. Okay, and we've got it on, and we'll run it the program again. You can see I'm holding it. Okay, but it's not really working. The reason being, it's run through this code, it's executed every line, it's got to this stage, and it said if it's pressed, send an instruction to the fan, else hold it, and then it's just done the beep, and then the program's ended. If I didn't have that beep, it wouldn't even have run. However, what we've got to do is, if you go back to the Python, we've got these while. We want to create a while loop, okay? And the simplest while loop we can do is while true. So let's write it like that. And you can see here, remember I was saying that getting the capitalization is important. You can see here, I've got to tab that in, and then it's inside. Now this true, I know that they should be blue. So when I type it with a capital, it will compile correctly. Now, this time, everything that's tabbed out here, and you can see if I come along here and collapse that, everything that's tabbed out is included in the while true section. If I tab this in, this EV3 speaker, it's now also included in the while true, okay? But I don't want it in there because I don't want it beeping continuously. Okay, so now we come up, run our program. Okay, and now it's a fan that works only when the button is pressed. That's quite a nifty little program. And you can see here, I guess one of the differences with Python, as you make simple programs can be a little bit harder than working with the EV3 software, but complex programs become much easier with Python, and that's the advantage. That's why all the programs in your phones, on your computers, are all written in text-based languages, because they become easier as your programs get more complex. All right, the next thing we want to do, okay, is we'll come back and we'll make this, rather than a loop that just works forever, we're going to change it to a conditional loop. So I'll stop that program, and remember we had the timer. Let's incorporate that in. And we'll say my timer, 1.time, and it's going to return that value, okay, that we saw used before. And if it's less than 5,000, okay. So this loop will stay alive now for 5 seconds. So if I just run this, it's a very quick example. Okay, you can see it's just running, and after 5 seconds, It should be, and you can see it's stopped. It's no longer working. So you can just start to build up more and more elaborate programs as you're going. Okay, and you can see you've got all the support you need. You can use W3 Schools. You've got the the support guide. Okay, one of the other things, just before we jump off, and I'm aware of time and we've got to jump off and cover the last few things. One thing I do want to show you is there's this this section here, and it's a really great improvement for as you get more and more advanced. I've just got to find where it is in here. Parameters. Oh, generic input-output devices. This one. Essentially, they've given you the tools to write drivers for sensors. So things like there's the for lump sensors. This is for those who are looking to use it in RoboCup, those sort of things. You can connect up all the different types of sensors and I2C sensors. For those, if you're not familiar with it, don't worry about what I'm talking about. But, and they give you, so the EV3 dev sensors as well are in here, and they give you sample code, which allows you can expand that out and how to read non-Lego sensors. So it's a really nice feature that they've added in, and how to write wrappers around those sensors as well, which is great. So to give you an example of what I'm talking about, we can pull up a little bit of code that I've created. I'll just find, open recent. I'll just expand this out. Okay. So open recent. So we've got basic reader. This is the one I want to show you initially. So I've got another little robot here, okay, and it's got a an IR seeker sensor here, and I've got an IR ball here as well. So you can see here, this is the code. These are the only bits of text that I'm using. I've imported from another library, so that's available in the standard extension that comes, the EV3 extension, and it's another library which allows you to read from the EV3 dev sensors. From that, I've labeled the My IR Seeker and connected up to a port. Then I'm printing, getting a direction, putting it to a variable, assigning it to a variable, and then printing that variable, okay? Now it comes through a bit as what's called a tuple, but don't worry about that. And it's the first number that I want to display. Understanding how this program works, this is a diagram of the sensor that I'm using on the actual robot. And when this ball, it's an IR ball, it emits infrared light. When it, depending where it's sitting, it will give me a reading. So if it's over on the left side of the sensor, it will give me a reading of 1 to 4. If it's directly in front, it will give me a reading of 5. And if it's over 6 to 9, it'll give me a reading of, sorry, if it's over to the right, it'll give me a reading of 6 to 9. Okay, so if I run this program and come down here, I've got to connect up. I'll disconnect the other one. Now it's Bluetooth connected. You can Bluetooth connect them. It's a little bit fiddly, but when it's working, it's fabulous. And highly worth trying to get it to run. So at the moment, we get the sensor and it's going to output, if it works, which it should for me. Wait a minute. It's got, okay. Now, this is a little bit of troubleshooting that we've got here. So you can see something's happened and I've got a problem with my program. And down in this output section here, it's come back and it's giving me some indication. It's telling me at line 23, okay, time argument, there's a time argument or parameter required, okay? And up here, okay, you can see I've used the time function, but it needs a, if you come back over here, it needs a parameter put in there or an argument. And here, I needed to put some time in there. So I want it to sample 10 times per second. Whoops. I want it to sample 10 times per second. You can see it if I download this program now. it should run. Okay, and whoops, let's make sure. Complete. Okay, you can see it's running, and you can see nothing much is happening. Okay, but you can see with the ball in front of it. Oh, wait a minute. Nothing. Okay, now it's not doing the scrolling. Okay, you can see here as I move the ball around. Why? Okay, I'll keep pulling that down, but you can see here, it's over here. If I put it in front, it changes to 5. If I put it over to the side here, I'm getting a reading of 3. It's down here in this output section, and you can see which side I've got the ball determines what reading we get. Okay, so how do you use that information? Okay, I'll just stop that program. Okay, so as I said, if we go back to the program itself, if the ball is over this section, we want the robot to turn to the left. If it's on this section, we want the robot to turn to the right, controlling the motors. And if it's straight ahead, if it gives a reading of 5, we want it to go straight ahead. And so here's a quick little program to demonstrate that. This would be a really simple little soccer robot. Okay, and we got to connect up. Still available for connection. And go over, debug that, run it. And if we're lucky, if I remove. Okay, so it's searching for the ball at the moment. And you can see here, no matter which way the ball rolls, and you can see it starts to chase it. So, and that's a very simple little bit of program. And you can see here, we're getting on the output on the screen, you're getting instructions of whether it's what number it is and which direction it's turning as well, and whether it's going straight or not. So that is basically the gist of what I wanted to show you in Python. It's some of it is more complex than some of you are probably ready for. It's really hard in a less than in a 1 hour session, if you like, to cover that. But for some of you, it shows you where it can go as well. Sorry, and I'll just swap back. Okay, yeah, so that just shows you, it basically covers off what I wanted to show you. For some of you, it will be, it's just to show you where you can go rather than, and what you can do. And come along to one of the face-to-face workshops when we renew those, when we restart those, and we do some really great activities which will help reinforce all that sort of stuff. All right, so we might now jump back to the PowerPoint. Okay, and we're just about to finish up. Okay, but before we do, we'll jump onto the online resources and where they are. Okay, and you can see there's a bunch of activities, and they split into real world activities relating to vehicles, those sort of things, and computer integrated manufacturing activities. And to find those, I just go to type in Lego education, always with the education, otherwise you end up off in the retail. Lego education lessons, click on that, the thing at the top. All right, we can go here to the Australian one. I'll just jump back there. Okay, the one up here, you see the language is set for US. The one down here, it's set to Australian. Always try and go to the Australian one because the lessons will have links to the Australian curriculum, which is what you want. Okay, come up here to go straight to the Python lessons, just do grades 9 to 12. And we've got the unit plans here. This is the computer integrated stuff. This is the autonomous vehicle lessons. You can see here there's 3 lessons in there, 4 lessons there. And open it up and you can see the lessons. So we'll just jump into this cruise control one quickly. And you can see the lessons are all broken up. Oh, sorry, I'm aware that I'm going slightly over time. My apologies. But the lesson plans here are broken up. Lego have used the 5E teaching method. And so they've got, and it breaks down how much time you should spend in each section. This is a great resource to go through, sorts of things you'll need, ignite a discussion. Any building tips, you can view the building instructions there. The great thing here is it also, it gives the kids the ability to transition from this block-based coding, which I think is fabulous, and it gives them a really good foundation for understanding text-based coding. And then, so the example and the lesson is done in block-based coding, and it's also done down here in the text-based coding. And you'll find, I'm pretty sure you'll find that you might find that in some of the sample programs that are in the user guide that I was showing you over here as well, down the bottom there. Some of those, oh no, perhaps they're not. But there's other things in there. But certainly you can just copy that text out, dump it into a file, dump it into a main.py file, that file we were working in, and it'll all recognize it. Comments will be in green, all that sort of stuff. And you can run that. So it's a great little resource for getting ideas of how you might program different and run different tasks with the robotics. All right, bearing in mind that people will have to go places and do things, we'll keep moving. And it wouldn't be complete without telling you that Spike Prime, which is pitched slightly lower, if you like, than the EV3, I'll show you a diagram of that, also has just released, you can run Python on it as well. So it's available to you. So to get that to work, you'd come in here, you'd click on a new project, and then you've got this section, it comes up, and this is the ordinary, which where you're coding in Scratch. You can click on Python, and it pops up with a little menu like this. And this is in a lot of ways, it's a simpler environment to start Python, and it's got tutorials here, that sort of thing. You're less likely to have some of the complexity of dealing with different software, and it's all integrated into one. But it's great to jump onto the Visual Code, Visual Studio Code environment as well, because it's a true developer's environment. So it's great to use as well. And that basically gets us to quotes and questions. Now, anyone who wants a quote, that sort of thing, I can put you in touch with your school rep. So for those sort of things, you can go onto the website, that sort of thing. If you're not sure who your school rep is, send me an email and I can point you in the right direction. But other than that, I think it's time to find out if there are any questions, and we'll open it up. I'll put Chris on first and see how we go. If I can find him, there he is. So we'll give him the option to unmute, and he should be able to open up his video as well. Okay,
Hi, James. We did have a question from Alan, who asked earlier on if there were any alternatives to Etcher for copying the image onto the SD card that you know of. He'd tried that.
He's tried that previously. I don't know of any others, but there would be on the web. It's writing to an SD card would be a fairly standard thing. So there should be others. I can't give a recommendation because I haven't looked it up, but I'm almost 100% sure that there would be other programs out there to use. I'm not sure why he's having trouble with it. It worked for me, but perhaps it's his school environment or something. Maybe he needs to use another computer which is outside the school environment just to write the SD cards, something like that. That might be a possibility.
Okay, the only other question, I'm not sure if Jane is still on, but he was asking about, with Python, about the spacing in capital letters. I said it does matter, but whether he wants to ask you any specific questions around that, maybe he could ask the line now, or you could unmute.
Well, I'll give participants the ability to unmute, and they can sort of take turns asking or something, but we can trial that. So people should be able to unmute, or we can leave. You can type them, still type them into the chat function. So I'll bring that up. Oh, and Chris has added in the chat function, Chris has added the URLs that you could use as well. Okay. All right. Hopefully there are some questions. Either people are thinking or they've fallen asleep or one or the other. But
I think there's a number of people who would like to be emailed the tutorial that found it really helpful.
Sorry, email.
Yeah, there's quite a few people who would like you to email the webinar. Oh,
the webinar. Yeah. Everyone will get links to it's been recorded. Everyone will get links to it. It'll go up on the MTA YouTube channel, and it'll be there to watch and refer back to at any stage. So, okay, great resource for Python student tracking. Okay. Okay, so yeah, Michael's added in that Grok Learning or whatever is an option for people. Oh, he's piped in, it's free till July. There you go. Start with Python, Dwyer writing, Visual Studio Code. Well, Visual Studio Code is just a coding environment. It's not a language in itself. It's just a developer's environment, if you like. So you would definitely start with Python, and if you're using the EV3, it's there are other languages you can code it with. There's Robot C. There's a few others which are Robot C is closer to a C-based language like C# or C. So yeah, but yeah, I would definitely use the Python. If you're not sure where to start, you might prefer to start with the Spike Prime Python and ease your way into using the Visual Studio Code that way. Get the kids familiar with it with Spike Prime, which is probably an easier start and more structured. What age groups is EV3 suitable for? Can it be used in the upper primary? Yes, it can. I'll just show you the next slide as well. Okay. On this slide, it shows you the continuum that, and so the early learning. Now, the we do sits around grades 3 and 4, and then you move into grade 5 and up. And Spike Prime is introduced because some people found the EV3 a bit intimidating, and Spike Prime is really built around making it easy to get started, making it with the idea of giving kids confidence. So it's not as intimidating as the EV3, but it doesn't scale as high. So the Spike Prime would be targeted around grade 5 through to year 8, roughly. These are sort of rough numbers. And some people will go outside that, that's no worries. And then so the Spike Prime sits around grade 5 to 8, and then the EV3 will sit around 5 up to year 12. So hopefully that helps with that question. What age groups?
Luke was asking about whether you can export a convert block-based coding in EV3 into Python.
Sorry, if you can export,
if you can export the EV3 coding into Python.
No, they won't be, if you're talking about the EV3 block-based coding, so you won't be able to transfer programs from that. No, you'd have to start from scratch. And so in that sense. Can Spike Prime be used with the EV3? So I Davey, yeah, so can Spike Prime be used with the EV3? In the sense that all the Lego can be put together, yes. You can use Scratch, so the official Scratch, not the Lego-based one. You can use the official Scratch and connect it that way. So I think there's Scratch 3.0, and you are able to have them interact and send each other messages through programs. But essentially, they tend to be used separately, although there are ways of integrating them, but they're not natively able to communicate with each other. So hopefully that's an answer. So depending how complex you want to make it. Can you use Python with the Lego Smart Hub, so in We Do, and Power Functions? I haven't played around with it. There's no support for that. At this stage, I suspect it would be, you might be, it's a project you would have to initiate, and it might be tricky. So, but in essence, there's no support for it, no. Okay. Both EV3 and Spike are low entry, high ceiling. Yep. Okay, that's you, Chris. Thank you. The user guide you had on the right, grabbing the code from that guide within one of the links we have been provided. Yes, it is. It's on that first page, but it's actually, the user guide is inside the software. So if I pull it up here, down in that extension there, open the user guide. So when you click on that, it'll jump to the HTML, it jump to your browser and open it up. So that's where the user guide is. It's accessible from within the Visual Studio Code. So it's from that extension there. Okay, it's nicely put together in that sense. Okay, thanks. Okay. Any other questions? Okay. If we don't get any, then yeah, we might finish up. How many people are left on? We've got 29. You should be able to. Have I given you the ability to unmute your microphones? I thought I had.
Yep.
Oh yeah. Okay. So yeah, if anyone wants to ask a question, otherwise we'll finish it up.
Hello, can you hear me?
Yes. Yep.
Hi, this is Luke. I just had a really quick question. I've got a group of year 5 to 7s who are doing some programming with the EV3.
Yep.
How appropriate is to kind of just throw them in and say, right, we've done the block programming, we're going to throw you some Python. Would they be able to pick that up pretty easily? Have you had much experience with like year 5s in particular, saying, this is Python?
Year 5s is really early because at that stage, there's so much to explore with the block-based coding still at that stage.
Yeah.
Like it's, get them into the competitions, whether it's FLL, whether it's RoboCup Junior, and there is so much you can do with the block-based coding. That's fabulous. Like it extends, really well. You hear lots of kids or students go from primary school into secondary school, and the teacher will bring out the EV3 and they go, oh, we've done the EV3. If by grade 6 you think you've done the EV3, you have no idea what it's capable of.
Yeah, because we did FLL last year, and they just worked with the block program, and they were pretty successful with that, and they enjoyed it. I guess, continue with the block programming is probably good enough for them in primary school, and then if they move on, they can go to Python or something similar to that.
Yeah. You might find some of the kids, as they start to accelerate the sort of the extension group, you might want to open it up and give them a bit of an idea and show them. I certainly, when I was teaching, would do that. I would, I'd give kids kits to take home over the weekend, and they'd come back with amazing stuff produced. So, because there's a learning curve, and but if you become familiar with it, you can do those sort of simple activities, and they will start to pick up. There's a lot of sort of typing errors, and where kids, I guess you want them to understand programming conceptually what an if-else statement is aimed to do.
Yep.
And then, you know, that they can very quickly, it'll overcome the frustration of, you know, where it doesn't compile from spelling mistakes, that sort of thing.
Yeah, makes sense. Easy.
Yeah.
Thank you.
Okay. All right. Okay. Anyone else? Nope. Okay. Well, in that case, thank you very much for your time and spending, you know, joining us. I hope it was useful and informative. And yeah, we'll see you next time. Hopefully, see you at a workshop, face-to-face workshop or something that we run in future. Okay. Thanks, everyone. Bye.